Hey guys, what is a school band's favorite month? March. Are they marching band? All right, okay. All righty. Today, you're going to be working on 2.1C and 2.1C and 2.1F actually go together. You're going to have this page of notes, and I'll show that to you in just a minute. For right now, in the back of the room, where our sentence starters are, you are going to need to get a workbook. The workbook looks like this. It's got someone throwing sand, and I believe it says understanding matter. At the top, it says Unit 1. You're going to want to go get this. You're going to want to put your name on the inside cover because they all look alike. The main focus of these notes is that you can describe the main properties of shape and volume for solids, liquids, and gases. So go get this thing. I'll pause for you. And now that you have it, you're going to open up to workbook page 11. And on workbook page 11, you are going to see this section of reading that's right down here. You are going to highlight anything, any details that have to do with shape or have to do with volume. You won't highlight everything, just the items about shape and volume as they relate to solids, liquids, and gases. So go ahead and pause while you do that. And when you're finished, I'll see you in just a moment. Next thing you're going to get is, now that we're back, you're going to get this one. It's called 2.1C. It's States of Matter Focus Notes. The good news is that you're only doing half of this. You're only going to fill out the ideas that are 2.1C, only 2.1C. So here we go. All right. Volume. So we'll start by writing volume at the top here, right here where it says volume. It's the amount of space that an object takes up. Go and pause or write it while I'm talking. So the volume, the space that an object takes up. So if we were to fill this with water, the volume is how much water is in there. When it comes to something like a cell phone, it's how much volume or how much space does this take up. So it's probably 3 inches this way and maybe maybe a quarter of an inch this way. And so you could use a math formula to figure out how much volume is in something. Now the word definite, and you're going to write the definition. The definite can mean certain or specific. So I'm going to write certain or specific. So when we talk about a solid, liquid, and gas, you're going to be using that definition. And so here you could write in volume here, and you'd write in definite there. And every solid, liquid, and gas that we're going to look at, and every solid, liquid, and gas period, is either going to have, you're going to determine whether it has a definite shape or a definite volume, whether it does or whether it doesn't. There's no in between. All right. So your first 3 states of matter in that third section are solids, like you learned in second grade, liquid, and gases. There is a fourth one that's called plasma. It's not common on Earth. It's mostly in the universe, which is vastly larger than our world. Now, solids, speaking of that word definite, they have a definite shape and a definite volume. So pause if you need to write this. But without changing this, this is not going to change its shape or volume. With a hammer, that's something different. If I throw it on the ground, it's something different. But the volume and the shape are definite. They don't change. Now, liquids are interesting because while liquids have a definite volume, pouring the water from What's Up with Matter Lab from one graduated cylinder to a beaker, that had the same volume. So it has a definite volume, but it has no definite shape. It can take the shape of whatever container you pour it into because liquids can flow. And now remember, as you're writing in this section, you're only writing in 2.1C, only writing in 2.1C right now. Gases, Gases have no definite shape whatsoever. They take the form of whatever container they happen to be in. You can squeeze them like you did with the balloon. You can change their structure. You can change their shape. And they have no definite volume because gases, they just go everywhere. They can they can change their shape. They can change their volume. They flow, and they're really easy to compress, very easy to compress. And so as you're taking these notes here, it's just going to be the 2.1c only, the 2.1c only. And the last thing that I want to talk to you about is a word that you can write this here if you want. It's fluid. And a fluid is any substance that flows. So technically, a liquid clearly is a fluid, but so is a gas. So now we're getting in these higher levels of science. Gases are fluids. Liquids are also fluids because they can both flow. They can flow like the girl that's in this picture here. When she's breathing out, the gases are flowing from out of her mouth out into the atmosphere. And you've got some honey on the top, and this honey is flowing from the container. And just like the waterfall is flowing as well. That's it, guys. Have a good day.